Ever wondered how a massive underpass road tunnel is built? It's not just about pouring concrete and placing steel. It's about precise blueprint readings, smart reinforcement details, and meticulous engineering. In today's video, we'll explore the blueprint drawings of an underpass road tunnel, focusing on the wall reinforcement, top slab details, and the role of starter bars and shear connectors. Whether you're curious about construction techniques or want to learn about concrete dimensions and steel reinforcement spacing, we are reading the blueprint drawing of the underpass road tunnel. The blueprint drawing has been divided into segments for the construction of the tunnel. In one segment, concrete is laid 3 times. First, for the foundation wall and the top slab. We have already discussed the first video of this in the previous lecture. In this lecture, we will talk about the wall and top slab. In this blueprint drawing, we will discuss the overview of the underpass road tunnel, concrete dimensions, and details of reinforcement. We are moving on to segment 1, and in this drawing you will see walls on both sides with a section given. Let's proceed to section AA. In the first step, the foundation concrete was done, and in the second step, the wall concrete will be done. Just as the foundation had concrete construction, the construction line on the top of the wall is also shown in the second step. In the third step, we are checking the slab dimension plan of the underpass road tunnel. Today's lecture is on the reinforcement plan of the underpass road tunnel. For the wall, the starter bars that come out of the foundation will be discussed regarding their overlap, which is 900 millimeters. The outer vertical steel bars have a spacing of 20 millimeters and are 100 millimeters in length, while the inner vertical steel bars also have a spacing of 20 millimeters and a length of 200 millimeters. The steel reinforcement on the other side is the same. Vertical steel bars have been provided on the outside because the pressure will come from the outside of the wall. Hence, said bars steel are provided on the outer side. The spacing of said bars is 16 millimeters at 200 millimeters, and at the top, a band steel bar is used, which will also be present inside the wall and on top of the slab. This wall concrete must be poured before the tunnel wall reinforcement detailing. We are reading the blueprint drawing of the underpass road tunnel wall, where the starter bars are used first, and their dimensions have been added. The steel bars that will be used on the outside of the wall are 136 pieces of 20 millimeter bars with a spacing of 100 millimeters. Additionally, there are 50 bars at the top with their dimensions provided. The band at the top consists of steel bars of 20 millimeters with a spacing of 200 millimeters, and this band will be added along with the outer vertical steel, leaving space for the top slab cover. The vertical steel bars inside the wall have a spacing of 20 millimeters at 200 millimeters, and their reinforcement details have also been provided, along with the dimensions of the steel. Between segment 1 and segment 2, there is a construction joint where shear connectors and additional U-bars have been used. The wall thickness is 500 millimeters, so the dimensions of the additional U-bars are 150 millimeters, and these steel bars of 12 millimeters will be used from bottom to top with a spacing of 200 millimeters. The tunnel wall side bar reinforcement detail consists of 43 pieces of 16 millimeter bars with a spacing of 200 millimeters, and their dimensions have also been included. One length is longer and one is shorter, and these will be provided on both sides of the wall with 43 pieces of 16 millimeter steel bars with a spacing of 200 millimeters provided from bottom to top. Now let's review the blueprint drawing for the underpass road tunnel top slab reinforcement details. The slab has the same steel bars provided at bottom 1 and top 1, which are 20 millimeter steel bars with a spacing of 200 millimeters. At bottom 2 and top 2, there are 16 millimeter steel bars with a spacing of 150 millimeters. In this blueprint drawing, we check the design of additional bars in the slab, wherein steel bars of 20 millimeters with a spacing of 200 millimeters will be added with additional B1 reinforcement. The top reinforcement will have steel bars of 20 millimeters with a spacing of 150 millimeters on both sides, along with additional bars. The underpass road tunnel top slab segment 1 bottom reinforcement plan in the Y direction has 69 pieces of steel bars of 20 millimeters with a spacing of 200 millimeters. B1 bars are marked 01 and their dimensions are also included. This B1 steel will be provided from the right side to the left side, and additional bars will also be mentioned that will be provided from the right side to the left side. The underpass road tunnel top slab segment 1 bottom reinforcement plan in the X direction contains 64 pieces of steel bars with a spacing of 150 millimeters and and B2 staggered bars will be used, which will consist of 2 pieces of steel bars. Along with this, an additional length of 3,000 millimeters will be added with an overlap noted, and this will also be provided. From the right side to the left side, the tunnel top slab segment one-top reinforcement plan in the X direction has 64 pieces of steel bars with a spacing of 150 millimeters. T2 staggered bars will be used, and 2 lengths of steel bars will be utilized, with the overlap occurring between the slabs. This steel will be provided from one side to the other side. The top reinforcement plan will have the same B1 and T1 bars. The same type of steel will be provided, and this will also be provided from one side to the other with a spacing of 200 millimeters. The tunnel top slab segment, one additional reinforcement plan, describes a construction joint where shear connector steel bars will be used as additional support. The slab thickness is 600 millimeters, and the thickness of the U steel bars is 200 millimeters, with one being provided at the bottom and another at the top, and shear connector steel bars will be used in between.